Cool, apologies. So I'm from Johnson Controls, as has been mentioned far too many times now. I'm going to go through the stacked infrastructure and what we learned when we built an IoT thing. So just to start, I'm Jack Hickey. I'm a software engineer at Johnson Controls, if you know Johnson Controls. They're just under 2 years, working on a research and development team. Yeah, my manager just walked in, that's kind of, yeah. So this is the spiel kind of from the website. Johnson Controls, we create intelligent buildings, efficient energy solutions, integrated infrastructure, and next generation transportation systems that work seamlessly together to deliver on the promise of smart cities and communities. I had to read through that about 4 times before I could do it that way. So essentially, smart buildings. So we have the smartest building in Ireland, I'm going to say. So we used to be Tyco. So Tyco have been in Cork for years and years and years. We merged with Johnson Controls last year. So that's why our platform is called Tyco One and not anything else so far. So this is the business case. We want all the data from all the things all the time. All the data is whatever a device can provide us, event data. All the things are fire panels, smoke alarms, security card readers, anything we can connect to the internet pretty much, and all the time pretty much just references that it needs to be highly reliable. So this is our stack at its most simplest. I'll just hold it. So we have a device, so whatever this might be, a fire panel, spits up some data, goes through our ingestion pipeline, and we store it, and then we can access the data over REST. That's the really simple one that we kind of throw around, but it gets a lot more complicated. So in just the left side, in the ingestion side, we're using all these technologies, MQTT, Storm, Kafka, Zookeeper, etc. And in this yellow part on the right in storage, we've got Mongo, Maria, HBase, Elasticsearch for indexing, and then security is done with OpenAM and OpenDJ. So I made a slightly more complicated data flow diagram so you can understand how we get a piece of information from a device, feed it through ingestion, and then do whatever it is we need to do with it. So the kind of pivotal thing here is Storm. Storm, I guess the way I think about it is it streams data and does some sort of computation on them. So essentially a spout, or what should I say? Storm is made up of topologies, and a topology is a spout and a bolt. A spout is some sort of inputted data, and then it streams that data to a bolt or multiple bolts to do some sort of work on them. So the simplest example we have here is the initial reading from a device. So say you have a fire panel, and it communicates over MQTT. So we have a spout that will consume from that device's, say the device posts to /events, if you're familiar with MQTT topics. The spout will consume from that, emit streams to a bolt or multiple bolts. In this case, it just sends it to one bolt, and all the bolt does is store it in Kafka. Kafka is essentially a queuing system, but it's a bit more complicated in how it actually works. It kind of does these nice partitions, and it's kind of like a commit log. So if something fails or a load of writes fail, you can actually easily roll back, and it's easy to replicate the data. So the next one is, so you see we're going from MQTT to Storm to Kafka and then back into Storm. So this is just the second part. So essentially we consume from a Kafka queue. So that might be, again, events. And then we emit multiple bolts. So this one just says, if it's an event, go store it in HBase. I won't go into too much detail on HBase, only that it's a column database, if anyone likes column databases. It's kind of complicated. And this is an example of what a topology would look like in terms of code. It's kind of pseudocode. I'm leaving out some complicated bits and pieces. But essentially, set up like an MQTT stream that listens on events and say, that's where I want my data to come from, and that's the bolt I want to do work on. And in this case, yeah, it's just, maybe that's not too clear. But it's kind of odd that the consuming of the data and the working on of the data is in the same class, but it means any work you need to do on data is easily split up. So this is another example, again with a Fire panel, but this time instead of just saving it off to a database, we want to do something with it in real time. So from that initial spout that's reading in that event data, we send one off to HBase, store it for long term or for accessing over REST later, and the other one we say, go check it against a set of rules, and if it matches, send it to GCM, like a push notification service, Google Cloud Messaging. So this is an example of our rules engine. So in a real world scenario, if a fire alarm sends an event that says, look, there's a fire, and once that actually gets into the rules bolt, we can look, and there's only two real important parts in this big JSON. The expression itself, so it's very similar to SQL. Essentially select all from message where the serial number of the device equals that. So that rule will watch for a device of that serial number, and if it matches it, it'll go do this action. So in this case, the action is send a message to this user with this information, and that would be the actual event that might come into the system. And it's just a small thing, but we're using a templating engine called Velocity to actually push, say, the status of fire into that message. So now I'm going to go over the infrastructure itself, so what it runs on and what it's like to develop on. One of the key things of the project when we started was to be cloud agnostic. There's loads of reasons for this. Legally, maybe we're not allowed to use AWS in a certain country or Azure in a certain country. Security-wise, maybe we want to operate somewhere like a government agency where they have to be internal. They can't have anything stored externally. And so far, we've actually deployed it on AWS, Azure, Cloudera. We're actually using some of their services directly, so we don't have to build it completely from scratch. And similar to Kyle's presentation, we kind of deploy everything we can with Docker containers. And our DevOps team are using Rancher and cattle orchestration. So when it's all set up and working nicely, eventually we can just say we need to deploy this whole stack of stuff and have them all, connect together properly, and then that'll go do that. So actually building services that plug into this platform and all the event data that exists, we still use Docker at that level. So if I want to write a service that actually pulls some data from HBase, just accessible over REST for a phone or whatever, that's actually deployed in Docker as well. And because of that, because of using containers and it being a microservices architecture, we can, in theory, build every single microservice in any language we want. So in Cork, we tend to build on Java and Spring. We also have a few services in Node. In other teams around the world, they might use Spring at all. They're using Jersey. There's even a few C# projects rooting around that also connect to the platform. And then on the actual client side, we're building websites with Angular, and we've plans to move to React soon, hopefully. We'll get there at some point. And there's also native iOS and Android teams. Yeah, the other thing is I've been here about 2 years in Johnson Controls, not the building. And when I started, the project was maybe a year old or something like that. And I was working on a year-old project, but it still felt like a new project because it was just an empty container. And I can say, yeah, I want this project in Spring, I want it in Java. We can test it, we can do it the way we like. So if 5 years down the line, the platform is still there. I mean, the platform will still be there 5 years down the line, and when you're working on it, it still won't be like you're working on a 5-year-old project. It'll be like you're working on something new. And yeah, rest between pretty much everything internally. So this is our particular challenges we kind of face with microservices. One of the things we ran into is we kind of made out our own proprietary configuration service, and that's difficult and hard to maintain in some ways. So ideally, we'd move to something pre-built like Spring Cloud, and HashiCorp do something called Console, which in theory would be more secure than what we have. At a kind of organizational level, component sharing can be difficult. So in theory, we're all meant to be kind of full stack developers, and if a microservice that the team in California worked on broke, we should be able to fix it. But they didn't use Spring, or maybe they didn't use Java at all, so we have to be able to work on that. And if we do go to the point of saying, well, we all need to use the same frameworks, that kind of has its own issues and kind of defeats the whole purpose of microservices in a way. Yeah, we've had some issues with API versioning. At the moment, we're kind of doing REST, but it's not completely RESTful. And this is kind of our own development fault, I guess, but we're looking at stuff like GraphQL, which is a Facebook technology, where the client essentially says, I want exactly this data, and the service provides it. So if, in REST, if you add new fields, you could potentially break clients, whereas GraphQL kind of gets around that. Error handling and logging. There's, I don't know, 25, maybe 30 microservices at this stage, and trying to get at a log in one of them can be a nightmare. So we've started doing an ELK implementation, or Elastic Stack, they changed their name to recently. So we should be able to really quickly find errors that happen in the system and track them down. But for the moment, you can potentially have to log directly into container. And there's still manual deployment steps. We haven't fully figured out all the rancher and cattle orchestration stuff. So these are just some basic examples of client stuff, actual apps that are using it. So the one on the left is for fire panel monitoring. So you get real-time events from fire panels. And the one on the right is kind of for management of fire panels. So you can put, I guess, virtually put fire panels in different hierarchies just to sort them and make them accessible. And this is a security example for a company called WSA. So they use a platform for their home security system. And it's built generically, so it doesn't have to be an event from a fire panel device. It can be an event of some type from a security system. And they're using that to send alerts to their users. And that's pretty much it. That's a picture of my cat. His name is Mr. Moo. We're hiring, I've been told to say, so that's my bit there. You can go to jobs.johnsoncontrols.com. And there's more cat pictures on my Twitter. More. If you request, I'll put up as many as you want. Yeah, any questions? I guess one thing to say is it's a massive project. There are loads and loads of parts. I haven't touched all of them, but I'll answer as much as I can if you have questions.
So is it that you use lots of open source technologies?
Oh yeah, sorry, I meant to mention that at the start. So the stack is open source. The project isn't open source.
Okay.
Yeah.
Which will be open sourcing it, of course.
I don't know. So yeah, Storm, Kafka, Zookeeper.
So it'll be up to anybody else to put all of this stuff together?
Yeah, they can.
You haven't open sourced.
No. They can look at this diagram and, do their level best. Cool. Yeah.
Do you for the MQTT coming in?
Yeah.
Do you have a cluster there or something to handle, or are you relying on Kafka to take the load off quickly?
No. So what we do is, we have IBM Message Site as our message broker, and this section here. So the reason we hit Storm twice is.
Yeah, that was my other question. Why did you go straight into Kafka actually?
For that kind of reason. So the first instance of Storm, its only job is to grab stuff off of MQTT and put it onto Kafka. Yeah, essentially.
Okay, and is that clustered then? It is.
I think
so. Is that fail safe? Where's the fail? Like, for example, if the MQTT. Well, first thing actually, is there MQTT cluster, or is it just one broker? Or?
I'm not entirely sure how the infrastructure is built out itself.
Oh, yeah.
I'm assuming there's clusters of multiple instances and stuff as there needs to be.
You're not relying on the AWS IoT gateway or whatever?
No, we're not using that. Like it's on AWS, but as in it's on S3, but it's not. We're not using their.
And the idea with Storm is that Kafka will be kind of quick enough to take the load off, is it?
Yeah, I believe so.
Okay.
Yeah. I didn't build that ingestion pipeline, but that's my understanding of it. Yes.
And you're using that for authentication, is it, or?
Yeah.
Was in the, okay.
There.
Jeff, what kind of roles are you hiring for? Just curious. I'm just curious. I know that sounded like a staged question.
As far as I know, there's 2 senior roles for Android and iOS developers. Potentially a mid full stack role as well. There's probably more. That's all I'm aware of.
All related to using this platform.
Some of them are, yes.
Okay.
Anything else?
Show me the rules.
Oh, sure.
Again.
Yeah.
There's a SQL-looking statement there, but is that for filtering through a single message? Or?
Yeah, it's for a single message. So the events at the bottom I have here, like the actual event bodies are much bigger. So the one on the bottom that just says key serial number status, like they're massive, I don't know, 70-line JSON objects. That's just for kind of display purposes. So the expression language is actually very handy in that way.
One more there on just on latency. You may not have it, but I'm wondering, do you have any applications there that require low latency? In other words, that if something happens, that the person needs to see it immediately, or that they would notice. So if they're in the house and a light goes on and it doesn't come on their phone for a while, they would notice. Or
Yeah, so
it's just there's a big pipeline there. I'm wondering how fast the stuff gets through.
Yeah, so there's kind of 2 things there. As far as I know, if we were to be the guys that say your building is on fire, the legality behind that would be massive. And obviously there's certain things you have to reach, specifications you have to reach to be that. So we won't be for the time being. I'm sure that day will come, but for the moment the fire panel goes off and the fire brigade is rung in their own old internal system. I guess latency-wise, I don't have the performance figures, but essentially, if we do need real-time data, it's the reason there's 2 bolts. That one goes and saves to the database, and one straight away goes to GCM and pushes.
Or it does go through Kafka, is it?
No, it does go through Kafka.
Yeah.
But
that seems to be faster. Do you have any, do you know if you have any applications where, apart from latency, but just the frequency, say, that you're looking at something live, like a graph or something moving up and down? Do you have any applications like that where it looks live to the user? Or?
Yeah, so these guys should get, so in the one to your left, like that red flashes with the 3 in it, and if there's a new emergency level event from one of their fire panels or whatever, that will update in real time.
Do they feel usable? They don't look slow or whatever?
As far as I know, they're fine. I haven't. Yeah, I didn't build that project, so I'm not too sure. Yeah. Cool. Anything else?
Nice.
Oh, there's one more. Cool.